Let me introduce Phan. Having spent the last 8 years at BioGill as an engineer and regional manager, Kevin now operates Kloud Water, an independent integrator specialising in assisting craft breweries with their wastewater. Kloud Water has successfully designed and delivered wastewater systems in craft breweries across Australia, simplifying wastewater treatment for owners and brewers while taking the guesswork out of submission approvals and environmental compliance. Welcome, Kevin.
Thank you.
And don't forget to put your questions through the app.
Hi, everyone. I know this is a third day for some, so I've made this presentation picture and video heavy and tried to make it as interesting and share as much value as I can. Welcome to my presentation. Wastewater, it doesn't need to be a problem, but so often is. So a bit of agenda for today's presentation. So we know what we're getting into. A bit about myself. We'll talk a bit about wastewater, particularly in a craft brewery, and how that actually materializes in different wastewater problems. And it's quite a messy thing, actually. It can get pretty deep. So that'll be very interesting to open and discuss. And then I will talk about some solutions that have gone into play, and talk about the nuances of how those solutions were delivered to the craft breweries to fit their needs. Okay, so a bit about myself. My name is Kevin, and I am an environmental engineer by background, but I like to think of myself as a wastewater solution specialist, a craft brewery wastewater solution specialist. I've spent almost a decade at BioGill. Some of you may have heard that name before, but with its recent acquisition by a Singaporean company, I've spun off to continue to focus and serve craft breweries in Australia and New Zealand. And hence Kloud Water was born as a natural extension, so I can continue the work I've been doing the last several years. And it's important now that I'm independent because with my ongoing connections with BioGill, I can now also incorporate other wastewater technologies so that the solutions and services that we can offer is actually fit for purpose, because wastewater solutions is more than just a particular component. And so during my time, every system with a tower bioreactor that you may see across the country, I've been involved with and often have designed myself. And that's our project manager, Jonah, down at Yard Kings in Morisset. So this is what our systems kind of look like and what you can imagine, especially for startup craft breweries. So what is craft brewery wastewater? I think we all know what it is. The simplest way to define it is whatever goes down the drain, because that's what actually ends up needing to be treated if you need to treat it. But if you want to go a little bit deeper, another question that you may ask is, where does your wastewater come from? So this little flow diagram over here demonstrates that. What typically we think of causing a wastewater is the volume. And so that volume is in your CIP, your rinsing, and also your washdowns. So that's where all your water is coming from, right? But actually, a lot of the concentration in your wastewater, which will end up being driving up those numbers when we're looking at samples, comes out of what typically we consider the solid removal stage, because the fine tube at the end there, where you're trying to tap that away, if you tap that away, actually is almost 100 times in some cases the concentration of the wastewater that you're coming over here. So that's what you want to be really careful of if you're not side streaming already. And if you're not side streaming, I would suggest that it's something that you really want to consider, especially if you're a small craft brewery. As I was explaining before, that if you do it earlier on, it's a system that you can start to implement and have your team understand the value of, and thus when you scale, they know how to incorporate that as part of their process. Now, when push comes to shove and the issue becomes a lot more intense, it can be even more of a challenge to ask your team, who's probably stretched thin already, to start incorporating processes to minimize the sort of liquid waste that's concentrated going down the drain. It's an easy and free thing that you can do, and it's probably one of the most effective things that you can do when it comes to wastewater management. Yeah, so I've got a little video over here that shows wastewater being demonstrated. So we've got canning here at Ghost of Brewing Co. with David and Helen. If you have a canning machine, you are very familiar with this, but obviously there's a bit of overflow that occurs during this process every time it occurs. And that's just essentially pure beer, right? Going down the drain. And beer of itself, obviously, we think is, it's what we drink, it's the liquid, it's liquid gold. So we don't think of it to be, very toxic in any shape or form. It's not compared to, heavy metals, but one can just visualize what the effect could be if you were to take, a gallon of beer and just throw it down the river. It's quite intensive in terms of the effect. And that's where your water eventually ends up going anyways, or it has to go through a centralized treatment system, which has to be sized well enough to treat that. So those are the mechanisms that's driving the concentration increases. So a lot from that, but also the sneaky one as well is true. So if we go a little bit deeper, these are the sample results that you typically might get. Or this is what it might look like. I'm sure some of you are quite familiar with some of these chemical nomenclature. What's really important typically is flows, which if you don't have a flow meter, there are ways that you can kind of forecast what that is, but typically you would have a flow meter. No, in many cases, no. From my experience, there is no flow meter, especially when a brewery is first conversating with me. But we can model that out. We can make estimations. We can say, hey, these are the ratios that we can apply. This is the average, but if you want to be conservative, you can choose this. If you want to be optimistic, you can choose that. And these are the implications, and this is what you should be expecting. So we always inform. And it lets you have more options to choose how you want to approach the wastewater problem. So flows, next is pH. Obviously, with the chemicals that you use as part of your CIP process, there's a fluctuation. Sometimes it's alkaline, sometimes it's acidic, right? So that's an important one that a lot of water authorities will look at and say, and ask you to keep that in check. And there's different functions that they need you to deliver on, whether that is completely secured and batched off and discharged, or if you want to get ahead of the curve and be proactive, you can simplify a little bit more. You could even have one-way dosing, which really says when you're having that conversation with a trade waste officer, brewery wastewater is typically acidic. And if we size our balance tank well enough, times where we're doing cleans where alkalinity increases, there's enough buffering capacity there. And so we will check it on a daily basis, right? And so if it does exceed, we will manually dose back down to a neutral level. And so what that means for you as a brewery owner or a brewery is that you don't need to purchase a two-way auto dosing system, which is sometimes significantly more expensive. Especially as a craft brewery, when you're starting off, you're not wanting to invest money here yet, and that's our philosophy over here. We get you all the way to the point where you absolutely then need to, then we hope to be right first of mind when it comes to wastewater treatment for you. But those are some of the things that you can do to cut down costs, and they're not very straightforward, but if you know it, then you know it. And then the other things are suspended solids. So that can be a particular issue depending on what the trade waste officer is saying. It's all really contingent on that relationship that you have and also what their needs are with their water system that they're trying to maintain downstream. And also the last one is your organics in BOD, which is your sugars, and then nitrogen and phosphorus, which typically may come through your cleaning agents. But BOD is becoming more and more of an issue especially right now, it's being felt by regional breweries. It will be, I hear I hear quite a bit of rumblings in the metropolitan areas, depending on which metro areas in Australia you're looking at. But it will come, and it's always good to be aware of it and then be informed and make that decision quickly and readily and informed when you come to that point. But I want to also show how these numbers can differ quite a lot from this sample, this brewery over here, to the next one I'm going to show you. And I want to point out the BOD, which is 10,000 for this case over here, and also your pH. Flows we don't really have over here. So that was 10,000 and around about 5.9 for pH. Here, even in the high scenario, and this was actually modeled by a consultant to deal with the brewery. So it's always changing. Every brewery has a different situation. They're much more optimistic because they had a consultant come in and they were trying to ask the consultant to portray their wastewater in a particular light, right? So my advice in that situation is that's fine. If you've looked at the numbers and you know your brewing process and you think that that's been demonstrated before, you can go for that, and we'll show you what our system, if you need treatment, will look like. But be informed that if you did find your wastewater samples to be a little bit higher than that, this is what you need as well. So we'll always table those options for you, and we can do that because we start the system design with modularity and scalability in mind. But those are the things that you want to think about, even though you might want to demonstrate your wastewater to be coming in at a very low level. Sometimes it might make a lot of sense, but in the long term, once you have the real world application and you're seeing your results come back and they're coming in out of a treatment system at, say, at safe. So it goes in, you're thinking it's going in at 1600, it may not be. And then you're treating it and it's coming out, say, 2000, and you're saying, what's going on here? We have to go back and we have to do sampling if you haven't done that already. So yeah, the different ways we can kind of explain how, do you want to choose 1600? Do you want to move for an industry average at 4000? Do you want to do sampling regime? That's probably what I'd advise, and looking at your process, that's probably as a general template, sample Monday, Wednesday, and Friday, middle of the day, the easiest way. Combine it all, send it off to a sample. That's going to be much more accurate as an example of how I would kind of address that, or you could address that. Okay, so priorities of a brewery. So different forms of wastewater problems, that's what we're talking about now. So typically, the priorities of a brewery are as such. So I just took this from some sort of strategy document. So high quality beer production, product portfolio, winning new customers, et cetera, et cetera. So this is what we're talking about. This is what you guys are talking about, probably on a daily basis or, a regular basis. This is what it should be, right? But wastewater becomes your priority when it becomes a problem, right? And this is how it can be. So it's a video that shows it just scrolling through. So you're all the way through the DA. You've gone through the process of securing the lease. You've bought the equipment. You're ready to put it in, and you've maybe had experience, or your brewer's had experience with brewing, maybe in Sydney, for example, where all your wastewater just go straight down the drain, right? And so you thought that maybe it's going to be the same process in your location. And especially with a lot of destination breweries and brew pubs setting up in Australia, you might think that's the case, and then you find out that because the regional location is serviced by a smaller treatment plant, because it's a smaller demographic, that you need to actually treat your wastewater and have a waste management plan. So as you saw that kind of flick right through, this is going to be tabled onto you at the last second, and then you have to kind of make sense of that, and then obviously form a plan to address your wastewater, which is not the most favorable thing to do right at the last second, right? Lease is secured, it's going to start soon, the equipment's already here. What do we have to do? And there's been, as I hear in the industry, many occasions where brewers are forced to do a particular solution because it might seem like the right thing, or it might get them the approval, but then find out, 6 months down the drain that this thing's not going to last them for very long, or it's causing them issues right now. So a particular issue is getting a septic tank essentially placed into the concrete. I've heard it happen not too long ago, not too far from here actually, and now that has odor issues. They had to rush the concrete cutting, and so the whole system, even though the tank is probably 15,000 maybe, ended up costing them $100,000 to actually execute on that project. And when you look at one of our modular systems before, the very base level, it's a fraction of the cost. So it's a big, yeah, it's a little upsetting. So compliance issues. So you've placed in the system, and I've had conversations before with trade waste officers, and look, there's just so many things that they're dealing with. So brewery wastewater is something that's relatively new, even for them to kind of deal with. And so especially small craft breweries. So if it kind of makes sense, they might approve it, but the general gist is that if they do approve it, it's up to you to prove that it will continue to work. So even though it kind of makes sense in some form, when you've installed it, they will just now come in and do the sampling. And then once they do the sampling, if the results don't come in line with what you need in all that documentation shared before, they will start to say, okay, well, sorry, we need you to get in line. And then there's a nagging thing in your 4 months into the startup of your brewery. That's not something that you want, right? You're unsure as to how much of an impact that is. The really worst case scenario is, a threat of a shutdown, which probably is very unlikely, but you can't get rid of that niggle, right? But it can also eventuate, if you're a bigger brewery or even a smaller brewery, to the next issue: discharge fees. So this is still part of the same sort of documentation, or a kind of parallel documentation. You can see how complicated it is, right? I don't know if it's on purpose, but it's, even for me, trying to make sense of it from the very first time, I just didn't understand why it had to be this complicated, but it is. But what you really want to know is that there's this equation. This is the most important equation out of all of it. I'm not going to try to explain it in terms of what each piece means, but in its entirety, it's an exponential equation, meaning that if you discharge a couple of times and you're not meeting target, the fee exponentially increases, like so. They won't call, I don't know if they actually call it an exponential, they won't even call it an exponential equation. It is. You can see, if you're into math, that's what it is. So that's what it means. So it's either a revenue making mechanism, and is that also a little thing that you want to have? It's just uncertainty. That's what I get, when I talk to brewers and brewery owners. That's what you feel, and this is the base template that most regional breweries will have to rely upon, because regional towns aren't having extensive, detailed plans for craft breweries. They work off a template, and they've got a lot of things to deal with. So this is what they work off, and this is what they apply. Okay, and then lastly, odors is a pretty obvious one. If you have a primitive system that's just a tank in the ground, especially if there's blowers in it, so a lot of solutions that propose that there might be an option for you are essentially a septic tank with blowers underneath. And so you've got wastewater going septic because maybe you're not managing the flows, the system hasn't managed the flows well, so you're getting throughout the week a bulk of tube, for example. No one's told you not to put tube down the drain, and then you're blowing it. And then agitating all those fatty acids, which are very odorous. So, and then if your brewery is anywhere, the system is anywhere close to your patrons, that's an issue in of itself as well. So that one is very clearly obvious. So, solutions. So here are the pre-existing options. You've got water treatment engineers and consultancies, and also you've got septic tank suppliers. Right, those are the obvious ones. Who's going to deal with wastewater? These guys typically do it. These guys do the consultancies and the engineering firms, and the specialists. They do wastewater treatment sites for the big food and beverage facilities, the food, the bev that you see in your supermarket, and onwards. Sewage treatment plants, mines, and whatnot. And then the septic tank suppliers, right? They'll do it for off-the-grid homes, and they'll look at your wastewater and say, hey, that's brewery wastewater. Potentially, that can go down our system. Yeah, it's happened before. So that's what the system, the market was before. Yeah, so over here, so just a bit of more context as to how the actual structures of the business work. So the size of the projects are much larger for these engineering companies, and so that requires a different design philosophy. So you can imagine if you're trying to design and detail out a solution for a much larger facility, you try to scale that back down to the needs of a craft brewery, there's gonna be a lot of overheads and considerations that will fit for a larger facility that have now been incorporated into yours, because they're not, it's unlikely they're going to try to change to adapt to your needs if they're running off a certain capital project. Their supporting team as well, if you think about it, they've got typically fleets of servicing teams. So having that means that they have to justify those costs. That's why up until now, there hasn't been really a reliable and consistent option for small craft breweries and small craft food and beverage. Here's an example as well. They can go a little bit more in detail. So this is a packaged solution. It's actually quite nice, I have to say. It's a pH correction system. The thing with this is that you're essentially shipping this whole system, depending where you are in the country, which is dead space, right? You've got a tank. If you're able to describe how this system works and give you the key components, what can be shipped is just in a little parcel, and you can actually get the tank yourself. And because you've set up a brewery, most of the work in terms of plumbing it up is often at times very straightforward. So do you need that work to be done by an engineering consultancy? And these pH systems aren't typically done by septic tank suppliers. So that's one way that we can start to deliver options to the brewery. And then obviously over here is just images of what the sort of products that they produce on the other side of things. So they're either over-engineering the solution or they're under-engineering the solution. So this is what we're doing now for craft breweries. So we've scaled it completely down. So the first module you'll see over here will be your holding tank, which will do your pH adjustment as well. So similar to that system over there. But we won't say, hey, you've got to purchase like this, right? We may just supply this component over here, give you the drawings, and say, and go walk you through it. You know, whatever way that you think is best for your destination, for your brewery, for your context. You've also got the biological component as well for treatment. And also now you have different components. So in metropolitan cities, you may be able to get away with just solid separation. So that's your screening. So we'll include that if that's what's required, so we'll understand that. And also we've got other components as well that for bigger breweries to remove your organics. Okay, so some solutions. So we've got a few case studies. I won't go into the details technically how the systems particularly work, but more of how we approach the problem. We can go into the details of how wastewater solutions are kind of all packaged together and how they work, but I think that takes a whole nother presentation in of itself. It will be more of a technical one. So Rupert and Wendana in Mullumbimby installed a couple of our systems. So when they were setting up their brewery, the council wasn't really aware of how to treat trade wastewater, craft brewery trade wastewater. So, and Mullumbimby is connected to a much smaller municipal treatment system. So council was not familiar with our system. So we held meetings with not only council, but also Rupert. So Rupert got to understand how the system worked a little bit more through that process before even signing any sort of papers. And we got to talk to council just to have that open conversation with them. What do you need? What's most important in this document for you? And then obviously give our own input ourselves as to what we thought made sense. And after that, we put together a proposal that takes in those inputs and was approved. And so Rupert now operates the system. He operates it autonomously and has much of an understanding of the system and its operation as he does his brewery. But no system is perfect, right? So we're not saying that we're perfect. So every system, it will have small pieces of concerns. And so Rupert picks up the phone and has a chat to me about that. So two of the things that occurred. So odor, right? This system is indoors. The system in of itself doesn't really have odors. It's actually, that's one of its main compelling points, but he was experiencing odor. So we had to troubleshoot that with him. So it's collaborative because we can't have a servicing fleet go all the way up to Mullumbimby every time because then that becomes price inhibitive for him to actually have a solution. So we get on the phone with him, we have a discussion, he helps us through and understands what's going on. We find out that because of the drains being left there for quite some time, I think it was maybe a week, a shutdown or something along those lines, even that can cause the wastewater to go septic. So now we both understand that it's actually very important to wash out your drains, right? Otherwise, that wastewater that's gone septic travels through to the system, and because the system works on a recirculation basis, right? That odor gets pushed up and you can actually experience it. So now he knows, and it's something that now I advise all my clients and all the breweries that I help. Second thing, filter flies. Filter flies is actually a pretty easy thing. We always communicate that from the very beginning. It's a little bit less likely to happen indoors. So in a biological system like so, you're essentially building a home for billions of microorganisms to drink your beer, essentially. But in due time, those microorganisms will have an ecosystem, and then they will form flies and larvae, and then they'll form into filter flies, which is unsightly. So we already have a tested insect growth regulator that we actually apply, and we know that it works. And so we say, hey, Rupert, we didn't think it'd happen this fast, but that's fine. We'll send you out that regulator, which will give you instructions as to how to apply it. Problem solved. This is a bit of a process flow diagram as how it looks. It can get more detailed than this. This is more very preliminary to a certain extent. But his system, goes into a in-ground pit. Gets pumped into a holding tank over here to fit the space that he wanted to allot to it. And then the system obviously recirculates continuously. There's pH dosing that occurs in this tank as well. And then this overflows into this tank over here and goes onto the oil water separator. So he had an oil water separator on his site, and he said, is there any way that we can actually make use of this? Otherwise it'd be wasted equipment, really. So we had a discussion with him whether it'd be good to have it before or after, and also educated him on how it would affect the system. And so now he can, he's empowered to actually test to see whether or not he prefers to have it at the beginning of his process or the end of his process. So he's actually chosen to move it back up to the front because it helps him collect the solids at the front, because that's more useful for him as opposed to collecting potential solids at the end, because this system actually treats really well biologically and doesn't create a lot of solids, he's found. And so it's better to have it at the front. But we won't go too much into detail here on this one in terms of the technical design of this. Another solution here, Lord Howe Island Brewery. So they're obviously located in a very hard to reach destination. You need a barge to get over there. And this is a really good example as well. During my time at BioGill, we reached out to some of our engineering partners and to get a solution to them to the standard that they're used to really was just project inhibitive, right? And so, but you can't have this brewery operating without an appropriate wastewater treatment system, because it's actually connected to a UNESCO World Heritage Site. So that wastewater doesn't have connection to trade waste, for example, right? So they needed to treat it down, otherwise they had to go kaput on the actual project itself. So I worked with the environmental consultants that they had, because this is with Lion, to identify the key risk factors that they were concerned about. The key things actually that they needed to address was a little bit different, because you had to get it out to such a protected application. So it actually was nitrogen and just obviously BOD as well, but nitrogen in particular. So as we specialize in brew wastewater, this is a process Kloud Water can quickly navigate, and we can often include as part of the solution service. Yeah, so I think there's a bit of a video which demonstrates Alistair on site running through the system.
Pit, from the brewery, water comes through this grey reinforced pipe, falls into our holding tank. The holding tank gets pumped out and recirced in a ratio to achieve a good flow level according to our reading on a flow meter. Then a pump inside the pit pumps past a pH meter through and gets pumped over the BioGill spray balls. Inside this recirculation tank, the pH is measured and then controlled by these two pumps that are neatly mounted on Tupperwares, and that doses acid and base. As water moves into the first BioGill, it naturally overflows into the second BioGill. Same thing happens where it recirculates over the top, and as water gets pushed through the system, it overflows by gravity into a third tank where it then either gets pumped through to filters and into an irrigation tank, which then goes to the jungle. Or if the water's not yet of quality, we'll close that valve and rather send it back to the beginning of the system for another lap or a few through the system.
Cool. So 2 key things about this project that made it a little bit difficult, and how we address that. So obviously being out on Lord Howe Island, it's very difficult to get anyone out there on the island to complete the works. So Alistair had to have confidence before the project proceeded that he could actually install the system. So we delivered on that before any signing occurred. And so as you can see, we didn't actually supply the pH dosing equipment there. He procured that himself, and we just specified what he needed there. So that obviously they helped him cut down costs. But obviously the installation there is a little bit rudimentary.
Pit.
So this is what the system looks like as well. So what's key here is that there's a dual return flow. So that's really important, and that's what we actually applied to help him reach the targets that he needed with certainty. So because it's so stringent on an island and you're not discharging it to your small decentralized, small treatment plant, you're actually discharging it straight to land, essentially reusing it. You need to have a sure, safe way to treat it again. Treat it down, and thus you have to treat it again. Now you can't always treat it again, otherwise it kind of doesn't make sense. So we explained to him what the mechanism is like and how it actually marries up with his brewing process. So some days he might not be brewing a lot, and those days are the right days for him to send it back out. So he's really clued into how it works now, and he's got a system that he can operate effectively. So another solution, 7 Mile Brewing Co. It's Matt. And this is the system there as well. So it's a similar style system, but their initial issue originally was they conducted they had a failing, how do you describe it? Like a baffled septic tank to a certain extent. And so that was advised by their another consultancy that said that would work. And so that caused a lot of odor. All your wastewater was going to this big tank with baffles in them. A lot of odor, and they were just not meeting their targets, and trade waste was really just, on them consistently, and they were paying fees as well for that as well. What does the system actually look like over here? So this is the system that's in place right now. It's originally what we did was we came in and we had a discussion with Matt as to what his flows were. We modeled those out. We also looked at the concentration of his wastewater, and we actually assessed his development his trade waste policy. So we understood what needed to be achieved, and then we looked at what sort of equipment that they already had on site and said, hey, Matt, like you don't need to get a brand new X, Y, and Z, like a pH system. You can actually install it yourself. You don't need a new holding tank. You've already got one over here that's unused, so you can use that yourself. and then we did the design of actually the pipe work as well for him. And over here, the BioGill system could have used a recirculation tank, but with a pump skid. So instead of having a pump skid and the controls with a pump skid, which can be very expensive, we opted for automatic submersible pumps, which minimizes the costs involved with the pumping skid. And so, again, no product is perfect. And so there's a couple of things that occurred at the brewery. One is there was a bit of excessive foaming that occurred, which you can kind of expect through brewery wastewater. It's quite a large system. So originally what we did was we returned the outlet pipe from here back down into the tank. We extended down a little bit further down so that it actually goes beneath the water line so that there is not to lower the agitation. Although that helped, there was still quite a bit of foaming, and that's due to the brewing cycle that's occurring. It's a little bit heavy on certain days, certain times. But we worked with their team, and Dan actually, one of the brewers over there, installed a sprinkler system, which actually has helped suppress the foaming that's occurring there. That was occurring while we were doing work in the background with our engineering partners, and we found a actual foam suppression nozzle that we will be sending out to the team, and that's an example of how we were going to troubleshoot that sort of solution with them. That occurred there. And yeah, so that's it for my presentation, and we'll do a bit of a Q&A now, if there's any questions.
Question.
Yes?
Do you only do BioGills, or do you do aeration vessels as well?
Yeah, we can do aeration vessels as well.
What's the downside of an aeration vessel?
You have to ensure certain conditions are met, so operation requirements are a little bit more stringent. And also, because a BioGill system is passively aerated, there's almost zero odor issues operating the unit itself. But if you have a aeration-based system, whether maybe MBBR or just maybe activated sludge, there's a higher risk of odor occurring, especially when wastewater gets septic, maybe in a holding tank, for example, and you're just agitating that up. And if you're closer to the patrons, as I said before, that can be a bit of an issue there, yeah. Yes?
I'm interested to know what sort of levels of BOD, TDS that you're achieving.
Yeah, so the targets for, the ones that go to smaller treatment systems, trade waste essentially, the targets are 300 milligrams per litre. Inlet for that one was, I forget the top of my head, but usually we set it at around 4,000, especially if it's a greenfield site. But we always talk with the brewery to see, this is what the industry average says. Can we always get a sample? But I don't have the numbers at the top of my head to what the inlet was for 7 Mile, for example.
Around 300 ppm BOD.
Correct, exactly. TDS is typically not an issue.
Because you can't change it on your system.
No. You'd have to have reverse osmosis to remove TDS, but typically that's not the red coloured risk profile for a treatment system and council, yeah.
That's right, because you're not going to get the condition of the water suitable for feed for that.
No.
It's more about safe disposal.
Correct, exactly. But if TDS was ever an issue, say land application, for example, we'd have to advise and do a bit of a process assessment upstream to see where that TDS is coming from. And typically it's some sort of chemicals that you're using as part of your cleaning process, and then investigate and reach out to our network to see if there is some options out there that they can use alternatively, because they're in that situation where they need to discharge out to land and they have that requirement. You're welcome. Any others? Good?
Thanks, Kevin. Round of applause for Kevin, everyone. That's very good.